those problems right there from the Pythagorean theorem, everybody's okay with those? All right, classifying the triangle as an acute, obtuse, or straight. It's good. All right, so I'm going to close that one then. We're going to start working with problems that involve some functions on the calculator that involve sine, cosine, and tangent. Okay, so we'll get to this worksheet later. All right, so we're going to talk about SOH CAH TOA. Let me erase that. So this is the handout that you guys got. Make sure you underline this right here, SOH CAH TOA. Those are what we're going to be using to solve these problems. Now, before we talk about those word problems and these terms right here, we're going to take a look at a little bit of history about Pythagorean theorem. Pythagorean theorem. All right. Now, take a look at right here. Just a couple things about the Pythagorean theorem. You notice this side measures 3, and this side measures 4, and this side measures 5. You guys see that? Notice this is a perfect square right here. 3 by 3 by 3. Notice this one's a perfect square. 4 by 4. And notice this one's also a perfect square, 5 by 5. Okay. It didn't matter what size we used. The only thing that we did have to make sure is that those sides made a right triangle. 3 squared plus 4 squared, that's to equal 5 squared. Yeah. 3 squared is 9, 9 plus 16 is 5, that's 25 equals 25. So, as long as you're going to use a squared plus b squared equals c squared, if the figure is a right triangle. Yeah. Now we talked about the triangle. If it's not a right triangle, you can use the Pythagorean theorem to determine if it's an acute or obtuse. Remember, acute, all the angles are less than 90. And if it's obtuse, one of the angles is bigger than 90. If it's one of them is exactly 90, then it's a right triangle. Okay? So it doesn't matter what the sides measure. If it does make a right triangle, those sides are going to be perfect squares on each part. Okay?
Pythagoras was born sometime between 600 and 590 BCE. His father was Mnesarchus, an international merchant from Samos, a Greek island in the Aegean Sea, and his mother was Parthenis, a Greek Apollonian. While traveling abroad near Delphi in Greece, Parthenis requested Mnesarchus visit the oracle to Apollo. The oracle informed the couple Parthenis was pregnant with a male child and instructed them to abstain from relations during the pregnancy. Parthenis changed her name to Pythagoras, but no record exists of her surviving the birth of her son, Pythagoras. Pythagoras traveled extensively with his father Mnesarchus during his formative years. Mnesarchus raised Pythagoras into the Median Persian cult of Zoroaster, the prophet and son of Ahura Mazda, the god of light. It is widely believed that Pythagoras was also initiated into the other religious cults of his day in all the lands he and his father traveled. These included, according to some, the Eleusinian mysteries of the Attica Peninsula, the Egyptian mysteries of Thebes, the Babylonian mysteries in Chaldea, and the cult of Adonis in Syria. Some believe it was from the Babylonian priestcraft while a prisoner in Chaldea that Pythagoras studied the theorem that he would later become most famous for inventing, the theorem for all right triangles that a squared plus b squared equals c squared. Although the cause and date of his father's death remain unknown, it is recorded that Pythagoras himself traveled as far east as modern Afghanistan, where the Brahmins of Elephanta and Ellora in Hindustan called him Yavanshara, the Ionian teacher. Pythagoras finally settled in Samos, his father's home, where he lived until the age of about 35, under the rule of the tyrant Polycrates. Around the year 550 BCE, Pythagoras went into self-exile from Samos and founded a university of mathematics in Croton, Italy, where he lived and taught for around 20 years. By about age 55, Pythagoras' school had gained significant enough political influence in the Council of 1000 who ruled Croton, that when one of their politicians, history reports his name is Cylon, although this is only a pseudonym for the younger mathematician Aces, refused to communalize his property, his discovery of the square root of 2, to the cult of Pythagoras, and was thus rejected from cult membership, thrown off a boat to be exact. Aces appealed to the Council of 1000 to have Pythagoras tried for criminal conspiracy against the state. Pythagoras fled Croton somewhere between 530 and 495 BCE, narrowly escaping a fire set by Hippasus and a mob at Pythagoras' wife Milo's house, with his disciples Archippus and Lasus. He fled from there to Rhegium, Italy, port town near the island of Sicily, where he parted with Archytas of Tarentum, another disciple, and from there set sail to Metapontum, in northeast Italy, the hometown of Aces, his would-be assassin, and took refuge in the temple there. He lived on sea cucumbers and honey until he eventually died of starvation in about 494 BCE at around the age of 100 years.
So a little bit about Pythagoras, about a couple of key words here, because we are going to use the Pythagorean theorem still. But if you notice, an angle of elevation is an angle between a horizontal line and the line of a sight from an observer to a higher object. So if you look at this angle right here, this angle here, but made up by these two sides, would be considered an angle of elevation. Angle of depression is an angle that looks down, an angle that is between a horizontal line and the line of sight that an observer has to lower themselves or lower the level of their eyesight. So we're going to talk about angle of depression and angle of elevation. If you notice, both of those angles are alternate interior angles of two lines that are horizontal. Horizontal lines are parallel lines. Okay. Now, the steps that we're going to be taking to solve problems are going to be reading and understanding the problem carefully, writing down what you know, either what they're giving you information or what you see in the picture, and then finding out what you're supposed to solve for. This step 2, the making a plan to get a problem, I think a couple of you guys need to start realizing you have to make a plan to figure what you're going to do to figure out the problem. And this kind of goes for anything. When you guys are stuck with something and you don't know what to do, make a plan. Figure something out. This is something that is critical thinking. Okay? It involves you trying to sometimes just sit down and figure out what do you do. The step 3 is to solve the problem. Most of you guys try to solve a problem. If you don't show your work, though, then you leave yourself to the possibility of, well, if you get the answer wrong or your answers don't match because it's not multiple choice test, how are you going to know what you did wrong if you didn't write it down? Okay? Write your work down. And then the last part is check your answer. Just because you got an answer doesn't mean it's correct. Check to make sure it makes sense. Does the number make sense of what is being asked? Okay? All right, so first thing we're going to do, you're going to read the problem carefully and you're going to follow these 4 steps to see if you can solve it. So go ahead and read example number 1, and then I'll give you a minute to try to set up something to solve it. All right, so here's the steps that we're going to follow. Read and understand the problem. What is it that you know, and what is it that you're going to find out? Those 2 parts are automatic. We're going to make a plan, and sometimes making a plan involves drawing a picture. Okay? Then we'll go to step 3 and 4. Okay? So if a 100-foot building casts an 88-foot shadow, what is the angle of elevation of the sun? So read the problem, make sure you understand what you just read. Now, try to think of a plan. What would help you here? What do you guys think would help you?
Visualize the building in the shadow.
Okay, so let's visualize the building and the shadow. Go ahead and draw something rectangular to represent a building, and draw a shadow that would represent on the building. Okay? Now, I'm going to say the sun is right there. So my sun is, I need the sun to cast a shadow, or some type of a light to cast a shadow. Okay? And then I need a line. You always should draw a horizontal line. And the reason why I drew it lower, because you guys realize the shadow is being cast on the building, and the building should be on a foundation that's flat. So here's my building. There's my building. And we need a shadow, so let's say the shadow is There's my shadow. Now, it also tells us some numbers. So it'd be important to put those numbers in places that you do know. So take a look at what I've done. So go ahead and put your pencils down real quick for me. If you haven't finished your drawing, that's okay. I'll give you 2 more seconds. Do you see in that picture a right triangle? Okay. See it, John? Hopefully you saw it. The right triangle is right there. And I'm given 2 numbers. One of them is the height of the building, so that's 100 feet. And that little exponent that looks like a 1 is the symbol for feet. If I put 2 of those symbols, that would mean inches. Okay? And I also know that the shadow is 88 feet. So, any questions right there on what I'm doing to set this up? Okay. Now you guys have the time to set it up. You need to focus now on how I'm setting this, okay? So step number 1 is read the problem, understand it, and make a plan. Most of the times, something visually is going to help you figure it out. You're going to have to draw a problem out, okay? The next step is to solve it. Now, before you solve it, what is it that we're being asked to solve, first of all? I know that the Pythagorean theorem, a squared plus b squared equals c squared, I can find the third side that's missing. But this side is the side that you would plug in for c. That's called your hypotenuse. Are they asking me for the hypotenuse? What are they asking me for? Angle of elevation of the sun. Now remember what the note said earlier about angle of elevation. It's something going up, right? So there's 2 angles here. From here, there's 2 angles here. And you see that the angle that is made here by this piece right here, the horizontal line from the sun would be going down as an angle. And that would be considered an angle of depression. Over here, the angle is going up. This would be an angle of elevation right there. And I need to know what this angle is that the sun is casting shadow on. You see that these 2 are alternate interior angles of each other and they're equal to each other. So what we really need is this angle right here. So I'm going to label it this symbol that looks like a 0, but it's a 0 with a slash through it. And that symbol is called theta. And it's supposed to represent the angle measurement. So that symbol is the angle measurement, that theta. Okay? So we're going to use what this introduction had, SOH CAH TOA. Now before we do that, we're going to do a little activity with the chlinometer. Okay? And a chlinometer lets us determine an angle. Right, so the chlinometers I just gave everybody, is a protractor with angle measurements, 90 degrees being right there. And we've attached a straw to it as our looking device. And what we're going to do is we're going to look with our eyes. And we want to make sure that when we use the clinometer that it's to our eye height. And the clinometer has a string attached to it with a little washer to weigh down. That washer, depending on if I have to look up, meaning angle of elevation, the clinometer's going to travel backwards. So if you want to go ahead and put the clinometer to your eye, now make sure the clinometer, the string is on the flat side of the protractor. On one of the sides, the straw sticking out, put it on the flat side. And I would probably hold it up somewhere in the front over here and put the straw eye level to your, however high your eye is from the floor right now. And now you got to make sure that you are going to keep this at 90. And I want everybody to look up with your clinometer to the ceiling. And look at where the ceiling and one of the walls meet. And hold it, that image in the middle of the straw, and then put your finger on the string so the string doesn't move anymore. Now the way I have it, the string came back here and it stopped at about 73 degrees, but you got to keep in mind I was at 90 degrees when it was flat horizontal. That doesn't mean that the angle that I looked up right now is 73 degrees. This angle is 90 minus the 73 that it landed on. So I only really looked up 23 degrees from my eyesight. And in 23 degrees, I was able to see the wall and where the ceiling met, right here. And that's where I had the image in the middle of my straw, right there. Now, if I know this angle measurement, and I know one of two things, if I know the distance between me and the wall, or I know the distance between the base of the wall and the height of it, or if I know the hypotenuse, which is opposite the 90-degree angle. Does everybody agree there's a 90-degree angle formed by the floor and the wall? And then there's also a 90-degree angle formed by the wall and the ceiling? Yeah. Well, right now we're going to do a little activity where we're going to go outside and we're going to go check out these trees, and we're going to try to figure out the angle length it takes for us to look at it. Because the next class, you guys are going to actually try to figure out what is the height of the tree and the height of our building outside. Okay? So you're going to bring your clinometers with you, okay? All right, so we just went outside and looked at the tree, and you guys used your eye, and you got an angle of elevation. And depending how close we were, the angle could get higher. So, for example, if I've been standing here, and I wanted to look at the top of the building, that angle was going to get bigger. Or, depending on the positioning of the sun, meaning the shadow is going to be casted differently. Okay. So first of all, the plan that we just made, we're going to now try to use SOH CAH TOA to solve it. So in your notes, SOH CAH TOA, SOH CAH TOA. In order for me to better have you learn it, I'll play you a little song that I've been playing in all my classes. Hopefully.
Yeah. You know what it is.
I've had technical difficulties lately.
Yeah, you know what it is. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, student that's nothing. When I'm doing math, that's nothing. When you see me in the class doing math, I'm using the tool. Put it down from the whiteboard to my notebook.
SOH CAH TOA. It's not responding. So do you see the initials, the way and the order in which they're written? That's going to be the first part, is that you learn that part, okay?
Learn the three ratios or you're gonna lose. Sign is opposite of what hypotenuse. Why you look confused? Which one you gonna choose? Cosine adjacent over hypotenuse. We're not done yet. Don't get complacent. Tangent is opposite over adjacent. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, student, that's nothing. When I'm doing math, that's nothing. When you see me in the class doing math, I'm using some toa. Put it down from the whiteboard to my notebook. Toa. Yeah, I'm using SOH TOA. Attacking these problems like Rocky Balboa. Geometry till I DIE. Shout out to my boy Mike in the 314. My boy E up in the 271. My boy Derivative. My boy Square Root. You know I got you, baby. Math World Records. Math side. I'm out.
Okay, so the jingle is to get you to remember these letters in that order, always. SOH, CAH, and TOA, okay? Now in the song it did give you the setup ratios to use, so we're going to set it up real quick, okay? The first one, the letter S represents the sine of an angle. And instead of an angle, we're going to use a letter called theta, which I've introduced to you already. And that theta, remember, is supposed to represent the angle measurement. Sine of an angle is equal to O over H. Okay. The next one is cosine of an angle is equal to A over H. And then the third one is tangent of an angle, or tangent of theta, is equal to O over A. So everybody have your calculators? Go ahead and turn on your calculators. From this point on, you guys are going to be using these types of calculators now. These are called graphing calculators, scientific calculators. Okay. The graphing part of it you won't need yet, but the scientific part of it that has degrees are what we're gonna use. Now, one of the things that I want to teach you guys is how to check that you're in the correct mode. If you're not in the correct mode, this is going to cause your errors in your answers. So everybody look for the plus button on the calculator. And the plus button, right above it, has the words M, E, M of it. That's the memory. Hit the blue button first, that second button over here on the top left corner. Then hit the plus button. You guys getting that screen right there? Okay. Okay. So what we're going to do is we're going to go to the memory and we're going to reset it. So either type in 7 or you can scroll down to 7 and hit enter. And then you get this screen right here. All right, we do want to reset all the RAM. So we do want to hit enter or type in 1. And we do want to reset it. So we need to scroll down to 2 or type 2 and hit enter, and you're going to have your screen say RAM clear. That'll usually help you out whenever there's some issues that you can't resolve. Now the next part is you got to check your mode. Go to the blue button, and right next to it is the mode button. Gotta hit the mode button. And are you guys getting this screen right here? Yep. Alright, we want to make sure that we have the word degree highlighted. And if you look at the screen, right now the word degree is not highlighted. I have to scroll down to radian and then scroll to the right, and then I need to hit enter so it can stay highlighted. When you do that, you should notice the word radian is no longer highlighted anymore. And that's telling you that you just changed the mode of the calculator from radians to degree mode. And the reason why you need to be able to do this constantly is because my Algebra 2 students are going to be using degrees and radians pretty soon. And they're using the same calculators that you guys are going to be using. So you guys got to keep that in mind, that you guys are always checking and doing it correctly. Okay? Alright, now the next part is going to be how are we going to use the sine, cosine, and tangent on the calculator. Does everybody see the buttons that say sine, cosine, and tangent on the calculator? Hopefully you see them. Highlight them. You guys see them right there? Sine, cosine, and tangent. Now, when we're solving problems and we know the side lengths, and let's say we're trying to figure out one of the side lengths, and we already know an angle, and we already know a side, and we're trying to figure out one more value, we're typically going to use those buttons, sine, cosine, and tangent. If we're trying to figure out an angle measurement, which is the case for this problem that we're doing right now, then we have to use the buttons that are in blue, and those buttons that are in blue, you guys see these buttons right there? They also say sine, cosine, and tangent. But do you notice that they're to the -1 power? We're going to use those when we need to find angle measurements, okay? So in this case right now, we need to use those buttons to help us solve for the angle in this problem, okay? And in order for you guys to be able to get access to any blue button on the calculator, you always have to hit the button that says second, that's blue, and then go to the button that represents the value that you're trying to get to. So if I were to try to get sine inverse, I'd have to hit second. Now I want to get out of this screen now that I'm done and I made the mode degrees. You can hit clear. And let's say I want to get the sine inverse to appear, so I have to hit the blue button. And then I hit the sine button, and then you notice it says sine to the -1 power. Whatever I put in there are the sine lengths that I measured. And that's because I'm trying to figure out an angle there. Okay. So we're going to fill that in right now. So just go ahead and put your calculator down for a little bit though. Now, when you guys use SOH CAH TOA, the first one, the SOH, is for sine only of an angle. The second one is cosine. And the third one is tangent. Very important that you keep in mind. Everybody see this angle right here that I circled in green? That's the angle I'm trying to find right there. That angle, when you draw a side, a line to the side opposite, that's your O side, your opposite side. Does everybody understand that the side opposite, the 90-degree angle, that's always your C value in the Pythagorean theorem? And that's also referred to as the hypotenuse. That's also referred to as the H. H is for hypotenuse. O is for opposite. I misspelled it. Oh well. Okay. And then the side that's adjacent to the angle is because that angle and that side are right next to each other. For example, out of the 4 walls in this classroom, which wall is adjacent to the English room? Everybody agree it's this wall that the screen's on? That's the wall that's adjacent because we both share that side together. Okay. Now keep in mind something. You guys see this blue angle I'm shading in? Right there? If that was the angle that I'm trying to find out, the opposite side changes, the adjacent side becomes the side that's right next to the angle I'm talking about. So it's very important that you're specific which angle in the triangle are you referring to, because that'll change which side is opposite and which side is adjacent. Very important that you keep that under consideration. If we go to the blue angle right here, and we're going to use sine, cosine, or tangent, the opposite side now is over here. The adjacent side is over here in blue. And you got to keep that in mind. Now we're not using that blue side, but I want you. Don't worry about it. Okay. So we're going to look at, do you notice that I have the adjacent side and the opposite side of this angle here in green right here? And that's the angle I labeled theta. Theta is the angle, theta is the Greek letter that we're going to use to represent an angle. Okay? Just like when you guys did scale factor, we used the letter K to represent scale factor. So I want you to take a look at sine is O over H. O means opposite, H means hypotenuse. Out of these three, I need the one that has opposite and adjacent in it. Cosine has adjacent and hypotenuse. Tangent has opposite and adjacent. That's the one that has the two sides that I know, and that one will help me find the angle that I'm missing. So go ahead and write this. Tangent of theta, that's the angle we're going to find out right now, is equal to the opposite. What number represents the side that's the opposite? 100. Divided by which side represents the adjacent thing? 88. Good. All right, now before you do anything, you're going to try to get the theta, which is the angle measurement, by itself. So you're not going to be able to do this. You can't do that. You can't divide by tangent of an angle like that. What we're going to do is we're going to do tangent inverse then to get theta by itself. So theta by itself then is now tangent inverse on the other side, or tangent to the -1, times 100/88. So now you're going to get your calculator out, and we're going to type in tangent inverse. So we're going to clear the screen right now. So I want tangent to the -1 to be on the screen. So what button do you think I should press first? Second button? Okay, go ahead and do that. And then what button should I press next? Tangent. All right, do you guys get tangent to the -1 on your screen? Yep, all right. And then you should have 100 inside of it. Hit the division button. 88, and I would just close the parentheses since the parentheses popped up, and then hit enter. And are you guys getting this number, 48.65? Okay. This tells me then theta, which represents the angle that the question is asking me about, is equal to 48.65 degrees. That's an angle measurement, okay? All right. Let's have you guys see if there's any questions then on that first example. All right. Do me a favor. I want you to take all 4 steps to try to figure out example number 2. I'm only going to give you guys about 2 minutes to try to set up the problem and see if you can plug in your information that you know, okay? I'm going to erase the first example because I have to move the screen up. So if you need it, let me know right now. If not, I'm going to erase it, okay? So the chairlift at a ski resort rises at an angle of 20.75 degrees and attains a vertical height of 1,200 feet. How far does the chairlift travel up the side of the mountain? So, have any of you guys ever been on a chairlift? Yeah? You have? No? No? Okay. So if you haven't, it's going to be a little bit difficult to visualize what's actually happening. You have, what are you visualizing when you're drawing something to help you? All right, bottom, top. So let's say the chairlift is right here. There is a point where the chairlift is going to reach the top of the mountain, yes? And then typically the chairlift goes down. Give me 1 second. So even if you've never been on there, can you see what you're really doing though? Is you're basically working with the right triangle? Yep. You guys agree that the ski resort lift rises at an angle, so that's an angle of elevation. You guys understand that's this angle right here? So that's the angle of elevation. That angle measures 20.75 degrees. Yeah. And then it says it attains a vertical height of 1,200 feet. That's from the bottom, so look up here, to the top of the mountain, that's 1,200 feet. How far does the chairlift travel up the side of a mountain? So you got to keep in mind a couple of things. So put your pencils down. Look at the information that I've labeled so far, okay? Now you didn't have to get fancy and start drawing everything like super accurate or anything like that. The main thing is that you got an idea there's a starting point, something's going up, reaches a top point. There's a height that's given. Here's your right triangle. And the information that you know is you know the opposite side of the angle that you're given. This side would be labeled your adjacent side. It's adjacent to the angle. The hypotenuse is always going to be opposite the 90 degrees. That does not change. The hypotenuse does not change, okay? The ones that can change are the opposite and the adjacent, okay? All right, from here, now you've got to write down, which one of those three has the information that will help you find the answer? Now, really quick, I skipped a step. The step was, what am I supposed to solve for? What am I supposed to solve for?
Distance.
A distance from the bottom to the top of the mountain, which happens to be the hypotenuse, the total length of the ski lift travel. Does everybody see that that's the hypotenuse in the picture? So I need hypotenuse and I need opposite in the function. So which one of the three? Sine? Sine has opposite and hypotenuse in it. That's the one you need. Yeah. You understand we're not going to use cosine? We're not going to use tangent. So we're going to use sine. So go ahead and set up sine. Sine, do I know the angle given?
20.75.
Okay, so then instead of writing theta, I'm writing that actual angle measurement that I know. Okay?
So not the negative.
So we're not going to do the sine inverse because we already know the angle measurement. When we don't know the angle measurement and that's what we're trying to solve, then we're going to use the sine inverse to find out the value. But remember, there are some things that typically you have to rearrange it so you can get the what you're looking for by itself. Okay. What's the opposite? 1200. Do you guys understand why I'm putting 1200 first? Because it's opposite divided by hypotenuse. And hypotenuse is what I'm trying to solve for. Do you guys agree? I'm going to label the hypotenuse to be equal to x. So I'm going to set it over x. Okay? Now I want you to look at that equation. Your goal in this equation is to solve for the letter x in that problem. Any suggestions on how can I get x completely by itself? Because right now it's on the denominator of a fraction. What can I do to move the letter x? So right now, as you guys are trying to think, I need you guys to give me some help up here. What can I do to get the letter X alone? Times it. Multiply both sides by x. X over x is 1. On the other side, you're going to get x sine of 20.75. That's x times the sine of 20.75. And you notice that 1200 now is by itself on the right side. Now do you realize that x is no longer on the denominator of the fraction? I've got one more step. If I'm multiplying by the sine of 20.75, I want to get the letter x to be alone. What do you think I could do right there to get x to be alone? Divide by all of that, okay? So when I divide by all of that, you just got to make sure you remember those become 1 and you're left with x is equal to 1200 divided by 20.75, so we need our calculator. Now take a look how you're going to type this into your calculator, okay? You can type it a couple different ways. You can write 1200, oops. You can write 1200, hit the division button, and then underneath there, you can do a couple different things. You can say, all right, I'm going to put a parentheses because I want the sine of 20.75. And you notice when I typed in the first parentheses and then I hit sine, sine has another parentheses there. So do you notice I have 2 parentheses? Right there. I need 2 parentheses on the other side. So you see those 2 parentheses that I added on there? If I only put one of those parentheses, look what happens. Right. Again, 3387. If I were to go back, if I were to delete that, let's see if it does it. Copy this to the somebody was getting an error on it, but I would say to be safe, stay consistent with the number of parentheses on both sides. The same. Do you see the number I'm getting is 3387.05 approximately? Does that sound like a reasonable answer for this question? And those units are in feet. Does that sound reasonable? That the ski lift travels 3,387.05 feet from the bottom till it reaches the top? You notice the height of the mountain is 1,200 feet. 3,387 feet sounds pretty accurate. Do you guys agree that the distance the ski lift travels should be greater than the height of the mountain in this case, since the angle is a small angle? We always got to check, are the answers, do they sound appropriate or not? If we would have got an answer of 33 feet, 33 feet would sound kind of weird if you're traveling 1,200 feet higher. That wouldn't make sense. Remember that the two shorter sides have to add up to be bigger than the biggest side? All right, let's see if you guys can set up example number 3. Okay? I'll give you 2 minutes on example number 3. While you're doing that, I'm going to erase number 2 unless you need it. All right, hopefully you guys were able to get through it. So let's go ahead and put your pencils down. If you're finishing something up, finish it. But hopefully you're starting to get the idea. You gotta figure out some type of a drawing to visually help you set something up. The drawing should have some right triangle inside of there. Okay? All right, go ahead and put pencils down. When you start drawing your pictures, go back and read the question to make sure it makes sense to you. It says the angle from the base to the top. Angle of the base to the top. Here's the top of the water slide. Top of slide. And here's the angle from the base. Is 13 degrees. That's an angle of elevation. The slide extends horizontally. That was the side that was the adjacent to the angle. That's this side right here. Okay. Estimate the height. Height is the side that's opposite. So we need something that has the opposite and the adjacent in it. Do you see why I'm going to use adjacent? I already have a number for that. I don't know a number for the opposite. So I need you to, tangent is correct. Cosine has adjacent and hypotenuse, so we're not going to use cosine. Sine has opposite over hypotenuse, we're not going to use that one, okay? And tangent is the one that has the two sides that we're going to use, okay? So set up your equation now. Tangent of 13 degrees is equal to, O means what? Opposite divided by the adjacent. So the opposite is the height that we don't know, and the adjacent is the 58.2 that we do know. So now, how do I solve that for h? What can I do? Multiply by what number? Or without? You're correct. Well, remember, your goal is to, not by 13, you want to get 58.2 out of the way, right? And it's being divided. Multiply by 58.2 to both sides. When you do that, you're going to get h by itself, and you're going to get 58.2 times the tangent of 13. So now with your calculator, you can type in 58 times tangent of 13, close the parentheses, hit enter. That gives me a height of 13.4, and I believe that's in meters. Does that number make sense for this problem? Well, I would say, yeah, 13.4 meters. The distance from the base, the 58.2, that number 13.4 meters is the height. That sounds like that is a reasonable answer. Okay. All right. Any questions on that part right there? No? All right. So we're going to stop there. Very important that you don't forget the little jingle to remind you the order of the letters. Okay. We're going to go ahead and put everything away. Let's put the cases on the calculators and make sure you slide them through.
Yeah, you know what it is. Soka Toa. Yeah, you know what it is. Soka Toa. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, that's stunting. When we see me at the time doing math, I'm using the Soka Toa. Put it down from the
Yeah, so it's permission folders. You don't have to worry about any homework.
treatment kills, or you're gonna lose. Science opposite of what you're about to lose. Why you look confused?
Yeah, you can put the whole thing.
We're not done yet. Don't get
All right.
Tangent is opposite over adjacent. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, that's nothing. When I'm doing math, that's nothing. When you see me in the class doing math, I'm using Soka Toa. Put it down from the white book to my notebook. Soka Toa. Yeah, I'm using Soka Toa. Attacking these problems like Rocky Balboa. Geometry. IE. Shout out to my boy Pi in the 324. My boy E up in the 271. My boy Derivative. My boy Square Root. You know I got you, baby. Macro Records. Math side.